You think you know what light is? Of course you do. Light is what lets you see. It comes from the sun, from light bulbs, from screens. It's bright, it's fast, it travels through space, it bounces off mirrors, it bends through lenses. Simple, obvious. Everyone knows what light is. Except you don't. Not really, because when you ask what light actually is, when you push past the comfortable everyday experience and ask what's physically there, what light is made of, how it works, the answer is so strange, so fundamentally weird, that it violates every intuition you have about reality. Light is not what you think it is. It's not waves, it's not particles, it's not energy flowing through space like water through a pipe. It's something else entirely. Something that doesn't fit into the categories your brain evolved to understand. And once you see what light really is, you can't unsee it. The world looks different, because light isn't just one thing among many. Light is how the universe communicates with itself. Let me show you what I mean. Start with the simple question. What is light made of? You might say photons, little particles of light. And that's not wrong, exactly. But it's not right either, because photons are not particles in the way you think of particles. They're not tiny balls flying through space. They're not marbles. They're not bullets. They're not little pieces of stuff. A photon is a quantum of electromagnetic radiation, a discrete packet of energy. But what does that mean? What is it actually? Not what does the math say? Not what does the theory predict? What is the physical thing you're talking about when you say photon? Here's where it gets uncomfortable. A photon is not a thing. It's an excitation of the electromagnetic field, and the electromagnetic field is not stuff. It's a mathematical object that assigns values to every point in space and time. The field is everywhere, always. When the field has certain values arranged in certain patterns, we call that a photon. But the photon isn't separate from the field. It's a ripple in the field, a localized disturbance, a wave packet of field excitation. You don't like this. You want there to be something there, some actual object, but there isn't. There's only the field. And the field is not made of anything. It's a fundamental entity. It doesn't reduce to something simpler. The field is what's real. The photon is just what we call certain configurations of the field. Now let's talk about what happens when light travels. You picture a photon moving through space, starting at the sun, flying across 93 million miles of vacuum, arriving at your eye 8 minutes later. A little particle on a journey, crossing the distance, moving from here to there. That picture is wrong. The photon doesn't travel through space. The excitation of the electromagnetic field propagates. The disturbance moves. But there's no object making the trip. Think of a wave on water. You see the wave moving across the surface, but the water itself isn't traveling horizontally. The water molecules move up and down. The wave pattern moves forward, but no water molecule makes the journey from one side of the pond to the other. Light is like that, except there's no medium, no water, no substance doing the waving. The field itself waves, and the wave is all there is. There's no underlying stuff that the wave is made of. The wave is the fundamental reality. But wait, if light is a wave, then it should behave like waves behave. Waves spread out, waves diffract, waves interfere with each other. And light does all of those things. Shine light through a narrow slit. It spreads out on the other side. Shine light through two slits. You get an interference pattern, alternating bright and dark bands. Classic wave behavior. Except light also behaves like particles. Send light at a detector, one photon at a time. The detector clicks. Discrete events. Individual impacts. Localized interactions. Particle behavior. You can't split a photon. You can't have half a photon. Photons are quantized. Discrete. Particle-like. Photon. So which is it? Wave or particle? And here's where every explanation you've ever heard breaks down. Because the answer is neither. And both. And something else entirely. Light is not a wave. Light is not a particle. Light is a quantum field excitation that exhibits wave-like properties in some experimental contexts and particle-like properties in other experimental contexts, but is fundamentally neither. It's a third category, a quantum object, something that has no classical analogy, something your brain cannot properly visualize because your brain evolved to understand rocks and rivers and thrown objects, not quantum fields. Here's an experiment that will break your intuition completely. Take a photon, a single photon, send it toward a half-silvered mirror, a mirror that reflects 50% of light and transmits 50%. What happens? Classical intuition says the photon either reflects or transmits. 50-50 chance. The photon is a particle. It takes one path or the other. You can't split a particle. So it goes one way with 50% probability, and the other way with 50% probability? Wrong. The photon goes both ways, simultaneously. The electromagnetic field excitation propagates along both paths, reflected and transmitted, both at once. This isn't uncertainty about which path it took. The photon genuinely takes both paths. The wave function, the mathematical description of the photon's state, includes components corresponding to both trajectories. Now put detectors at the end of both paths. When you check, you find the photon at one detector or the other. Never both. Discrete detection. Particle-like. But if you don't put detectors there, if you instead bring the two paths back together with another mirror and let them interfere, you get an interference pattern. The two components of the wave function interact with each other. Wave-like. The photon went both ways, until you measured which way it went. Then it was only one way. The act of measurement changes what happened. Not what you know about what happened. What actually happened. Before measurement, both paths. After measurement, one path. The measurement doesn't reveal a pre-existing reality. It creates a definite reality from an indeterminate one. This is not a measurement problem. This is not observer dependence, in some mystical sense. This is quantum mechanics. This is how the universe works, at the fundamental level. And light, being a quantum field, obeys these rules completely. Now let's talk about speed. Light travels at a specific speed, 299, 792, 458 meters per second in vacuum. Exactly. This isn't a measured value that might change with better instruments. It's a defined constant. The meter is now defined in terms of the speed of light. Light speed is built into the structure of space-time itself. But here's what's strange. Light always travels at this speed. Always. No matter who measures it. No matter how fast you're moving. You can be standing still and measure light speed. You get psi. You can be moving at 99% of light speed and measure light coming toward you. You still get psi, not c plus your speed. Just c. The same value? This should be impossible. Speed should add. If you're on a train moving at 50 miles per hour and you throw a ball forward at 10 miles per hour, the ball is moving at 60 miles per hour relative to the ground. That's how speeds work in everyday experience. But light doesn't do this. Light always moves at c relative to you, regardless of your motion. Einstein realized what this means. Space and time must be flexible. They must adjust to keep light speed constant for all observers. If you move faster, time slows down for you and distances contract for you, by exactly the right amount to make light still move at c from your perspective. Space-time is not a fixed stage. It's dynamic. It bends and stretches to preserve the constancy of light speed. Why? Because light speed isn't the speed of light. Light speed is the speed at which causality propagates. It's the maximum rate at which information can travel through space-time. It's a structural feature of the universe. Light happens to travel at this speed because photons have no mass. But the speed itself is more fundamental than light. It's the conversion factor between space and time, the speed at which now propagates. And here's something that should genuinely disturb you. From the photon's perspective, no time passes. A photon emitted from a distant star and a photon absorbed by your eye billions of years later. From the photon's perspective, those events are simultaneous. Zero elapsed time. The photon doesn't experience duration. It doesn't have a reference frame in the usual sense. It's emitted and absorbed in the same instant, from its own non-existent perspective. You exist in time. You move through space and through time. But photons don't. They move through space at light speed, which means they move through time at zero speed. Time doesn't pass for them. They are emitted and absorbed, and between those events no time elapses for the photon. The entire journey, no matter how many billions of light years, is instantaneous from the photon's viewpoint. Now let's talk about what light does. Light carries energy. That's why sunlight warms your skin. That's why concentrated light can burn. The energy is proportional to frequency. Higher frequency light, like ultraviolet or X-rays, carries more energy per photon than lower frequency light, like infrared or radio waves. This is why UV light causes sunburns, and visible light doesn't. More energy per photon means more damage per interaction, but light also carries momentum. Photons have no mass, but they have momentum. This seems contradictory. Momentum is mass times velocity. If mass is zero, momentum should be zero. But that's classical mechanics. In relativity, momentum depends on energy and speed, not just mass. Massless particles moving at light speed can have momentum. And they do. You can measure this. Shine light on a reflective surface. The light exerts pressure, radiation pressure. Tiny but measurable. Photons bouncing off the surface transfer momentum. This is why comets have tails. Solar radiation pressure pushes dust and gas away from the sun. This is why solar sails could theoretically work. Photons hitting a large reflective sail could accelerate a spacecraft. Slowly but continuously. Light also carries angular momentum. Photons can have spin, not physical rotation, because photons aren't objects that can spin. But angular momentum is real. Photons can be circularly polarized, which corresponds to a spin state, and that spin can be transferred to matter. Shine circularly polarized light on certain materials, and they start rotating. Optical angular momentum transferred to mechanical angular momentum. Light does things. It pushes, it spins, it heats, it ionizes atoms. It breaks chemical bonds. It drives photosynthesis. It enables vision. It carries information. All of this from excitations of the electromagnetic field propagating through space-time. Now let's go deeper. What is the electromagnetic field? It's a vector field. At every point in space, the field has a direction and a magnitude. The electric field points in some direction with some strength. The magnetic field points in some direction with some strength. These two fields are coupled. Changing electric fields create magnetic fields. Changing magnetic fields create electric fields. They're not separate, they're two aspects of a single electromagnetic field, and light is a self-sustaining oscillation in this field. An electric field changing in time creates a magnetic field. That magnetic field changing in time creates an electric field. The two fields perpetuate each other, propagating forward at light speed. That's what light is. A coupled oscillation of electric and magnetic fields, self-generating, self-propagating, moving through space as a wave. But the field itself, what is it made of? Nothing. The field is fundamental. It's not made of smaller parts. It's not a substance. It's not a thing in the usual sense. It's a mathematical structure that describes how space responds to charges. Charges create fields. Fields exert forces on charges. The field is the intermediary, the mechanism by which one charge influences another across distance. In classical electromagnetism, the field is continuous. It can have any value. But quantum mechanics says the field is quantized. The energy in the field comes in discrete packets, photons. You cannot have half a photon's worth of field energy. You can have 1 photon, 2 photons, 1,000,000 photons, but not 1.5 photons. The field excitations are quantized. And here's where it gets truly strange. Even when there are no photons, the field is still there. The vacuum state, 0 photons. But the field has 0-point energy. Quantum fluctuations. Virtual photons popping in and out of existence. The vacuum is not empty. It seethes with activity at quantum scales. Particles and antiparticles appearing briefly, then annihilating. The electromagnetic field fluctuating, never truly still. These fluctuations are not philosophical speculation. They have measurable effects. The Casimir effect. Put two metal plates very close together in a vacuum. The plates attract each other, not because of gravity or electrostatics, because the quantum fluctuations of the electromagnetic field between the plates are restricted. Certain wavelengths don't fit. Outside the plates, all wavelengths can fluctuate. The imbalance creates a net force. Vacuum energy pushing the plates together. This has been measured. The vacuum is real. It's active. It has structure. Light interacts with this vacuum. A photon traveling through space is constantly interacting with virtual particles. Electrons and positrons popping into existence, interacting with the photon, disappearing again. This affects the photon's properties. Its energy shifts slightly. Its path deviates minutely. These effects are tiny, but real and measurable. Now think about what this means. Light is not a thing traveling through empty space. Light is a quantized excitation of a field that permeates all of space-time, propagating through a vacuum that is itself seething with quantum fluctuations, interacting continuously with virtual particles, exhibiting both wave-like and particle-like properties depending on how you measure it, carrying energy and momentum and angular momentum, bending space-time ever so slightly through its mass-equivalent energy, following null geodesics through curved space-time geometry. That's what light is. Not a simple particle, not a simple wave, a quantum field phenomenon, embedded in the structure of space-time itself. And here's the part that should make you deeply uncomfortable. You see, because photons hit your retina, those photons originated from objects around you. Electrons in those objects were in excited states. They dropped to lower energy states. The energy difference was emitted as photons. Those photons traveled through space, through air, through the lens of your eye, and struck molecules in your retina. The photons were absorbed. The molecules changed state. That triggered a cascade of chemical signals. Electrical impulses traveled along your optic nerve to your brain, and your brain constructed the experience of seeing. But here's the thing. The photon that left the object and the photon that hit your retina are not the same photon. Not in any meaningful sense, because photons are indistinguishable. There's no identity tag on a photon. There's no this photon versus that photon. Photons are excitations of a quantum field. They're patterns, not objects. When a photon is absorbed, the field excitation disappears. When a photon is emitted, a new excitation appears. The new excitation might have the same energy, the same momentum, the same polarization, but it's not the same photon in the sense that two electrons are different electrons. Photons don't have persistent identity. In fact, the whole concept of a photon traveling from source to detector is suspect. What actually happens is this. The electromagnetic field is in a certain state near the source. That state evolves according to the field equations. The evolution of the field state eventually influences the field state near the detector. We describe this process by saying a photon traveled from source to detector. But that's a convenient fiction. What really happened is that the field changed globally. The change propagated at light speed. The source and detector are coupled through the field. The photon is a way of talking about that coupling. A bookkeeping device, not an object making a journey. This is quantum field theory. The most accurate description of light we have. And it's profoundly strange. Light is not made of particles traveling through space. Light is the quantum behavior of a field that exists everywhere. Photons are excitations of that field. Discrete, quantized, but not localized objects in the usual sense. They don't have definite positions. They don't have trajectories. They have wave functions that evolve and interact and sometimes collapse into definite measurement outcomes. And all of this connects back to the fundamental question. What is light? Light is how the electromagnetic force propagates. When you push on a charged particle here, another charged particle over there feels a force. That force doesn't act instantaneously. It propagates at light speed. The field mediates the interaction. And the mediator, the carrier of the electromagnetic force, is the photon. Every time you see something, you're detecting photons emitted or scattered by that object. Every time you feel warmth from the sun, you're absorbing photons that traveled from the sun to your skin. Every time you use electricity, you're manipulating the electromagnetic field, creating field configurations that propagate and do work. Light is the visible manifestation of the electromagnetic interaction. It's not a separate phenomenon. It's the electromagnetic force in motion. And the electromagnetic force is one of the four fundamental forces. Gravity, electromagnetism, strong nuclear force, weak nuclear force. These are the forces that govern everything. And three of them, electromagnetism, strong and weak, are all mediated by quantum field excitations. Photons for electromagnetism, gluons for strong force, Lebesgue and Z bosons for weak force. Forces are not mysterious pulls or pushes. Forces are particles being exchanged, field excitations propagating between interacting entities. You push on a wall, you feel resistance. That resistance is electromagnetic repulsion. Electrons in your hand repelling electrons in the wall. That repulsion is mediated by virtual photons, constantly being exchanged. Too quick to measure directly, but their effect is macroscopic. Solid matter, contact forces, all electromagnetic, all mediated by photons. Light is everywhere. It's fundamental. It's how the universe communicates. Every interaction involving charged particles, every chemical bond, every reflection, every absorption, every emission, all of it mediated by the electromagnetic field, by photons. Real and virtual, propagating through space-time, carrying information, transferring energy, connecting everything to everything else. And you, right now, are surrounded by light. Visible light from your screen or your surroundings. Infrared light radiating from warm objects. Radio waves from communication devices. Microwaves from ovens and routers. All of it is electromagnetic radiation. All of it is excitations of the same field. Different frequencies, different energies, same fundamental phenomena. The field is everywhere. The field is always active. You live inside an electromagnetic field that is constantly fluctuating, constantly carrying information, constantly mediating interactions. You cannot escape it. You cannot turn it off. The field is a fundamental part of space-time. Remove all photons, the field remains. The field is not made of photons. Photons are made of the field. The field is the primary reality. Photons are quantized disturbances in that reality. This is what light is. Not rays, not particles, not waves in a medium. Quantized excitations of the electromagnetic quantum field, propagating through space-time at the maximum speed of causality, exhibiting wave-particle duality, carrying energy and momentum and information, mediating electromagnetic interactions, connecting all charged particles in the universe, and making vision, chemistry, and life itself possible. That's the answer. Not simple, not comforting, not something you can picture in your head accurately, but true. Light is a quantum field phenomenon, and understanding that means accepting that the universe at the fundamental level does not behave like anything in your everyday experience. It's stranger, deeper, more mathematical, and more beautiful than any simple picture could ever capture. Reality does not care whether you can visualize it. It only cares about being consistent. And the physics of light, bizarre as it is consistent. The equations work, the predictions match experiments to extraordinary precision. And if you want to know what light is, that's the answer. Not the comfortable answer, the true one.